Right now, the universe itself is still expanding faster than physics says it should, and the smartest minds at NASA, Harvard, and Caltech have no way to stop it or even explain it. Two teams measured the same expanding universe using two completely different methods. They got two different answers. Both are correct. And what that means for everything you think you know about reality is the part they're afraid to say out loud. Scientists call it the Hubble Tension, but forget the name for a second. Picture this instead: space itself, stretching right now faster in one direction of measurement than the other. One team looked nearby. They tracked pulsing stars called Cepheids, blinking like cosmic lighthouses in galaxies close to us, and used them to measure how fast space is expanding today. The other team looked all the way back to the faint afterglow of the Big Bang itself, a cosmic fossil called the microwave background, 13.8 billion years old. Two methods. Two windows into the same universe. They should have agreed. They didn't. The nearby measurement says the universe is expanding at about 73 kilometers per second for every million parsecs of distance. The ancient measurement, the one baked into the oldest light in existence, says 67. That's not a rounding error. That's a 9% gap. And in cosmology, a field built on decimal points, 9% isn't a mistake. It's a scream. For years, researchers assumed one measurement was simply wrong, a miscalibrated star, a dusty galaxy throwing off the numbers. So they checked again and again. Harvard remeasured it. Caltech remeasured it. The European Space Agency remeasured it. The gap didn't close, it grew. Here's why that terrifies people who study the sky for a living. If one measurement were wrong, this would be an easy fix: recalibrate, publish a correction, move on. But both measurements keep getting more precise, and the gap keeps refusing to disappear. That means the obvious explanation, human error, is off the table. Something in our model of the universe itself is broken. And nobody, not at NASA, not at Yale, not at any observatory on Earth, can tell you what it is. But that's not even the part that worries them most. Here's the part they didn't want to say publicly for a long time. If both numbers are correct, and every new instrument keeps proving they are, then the universe isn't just expanding. It's expanding at a rate that changes depending on when in cosmic history you're looking. Something happened between the early universe and now. Something sped it up, or something is bending our ability to measure it, and we don't know which. One theory says there's a mysterious form of early dark energy that gave the infant universe an extra kick, then vanished. Another says space itself isn't smooth, that we might be sitting inside a vast, unusually empty pocket of the cosmos, a void nearly 1 billion light-years across, warping our local measurements. A darker theory still, that the equations underneath general relativity, the ones Einstein handed us over a century ago, simply stop working at cosmic scales. Not wrong exactly. Incomplete. In 2026, that number, the exact size of the gap, is still climbing with every new telescope that checks it. The James Webb Space Telescope was supposed to settle this. It didn't. It made the tension worse, confirming the nearby measurement with even less room for error. The universe is arguing with itself, and it's winning. Think about what this actually means. Every distance NASA has ever calculated to a distant galaxy. Every age assigned to a star cluster. Every model of how the universe will end, freeze, tear apart, or collapse. All of it rests on knowing exactly how fast space expands. If that number isn't fixed, if it depends on where and when you're standing in the universe's 14 billion year story, then the ruler we've used to measure everything beyond Earth might be bending in our hands. It's not just an astronomy problem anymore. It's a question about whether the universe follows one set of rules everywhere for all time, or whether reality itself has fine print nobody has read yet. So here's what nobody at Caltech or Harvard will put in a headline. The gap between those two numbers hasn't closed in over a decade of trying. It's growing, which means either our model of the universe is wrong, or the universe is doing something we don't have language for yet. Which one do you think it is? Drop your theory below, because right now, even the experts are just guessing.